What's going on, everybody? Welcome back to my YouTube channel. Now look at this nice and beautiful question that we have here on the board that we're going to be solving. And the question says, if x, y, and z are positive integers such that x is the largest and z is the smallest, and they satisfy 1 over x plus 2 over y plus 3 over z equal to 1, find the values of x, y, and z. Well, in order to determine the numbers of possible cases, we're going to be applying boundings to x, y, and z. And since z is the smallest, my focus will be on z. Also, by nature, since x, y, and z are positive integers, it goes on to say that 3 over z must be less than 1. So let's write that down. 3 over z must be less than 1. Well, this is going to be our first step. We're going to be cross-multiplying this expression. So when I cross-multiply this, I'm going to be having 3 to be less than z. So let's split the positions. So I'll be having z to be greater than 3. In other words, we are saying that z is at least 4. So our next step will be for us to compare each of these expressions to z. For example, comparing 1 over x to 1 over z, we can gladly say that 1 over x is lesser than 1 over z. Why? Because the larger the denominator, the smaller the number. Well, since x is larger than z, that goes on to say that 1 over x is lesser than 1 over z. We do the same thing to this second expression, which is 2 over y. This should be lesser than 2 over z because of the same reason. So now let's write this expression again. That means the left-hand side of this expression, left-hand side, is lesser than, wherever I see 1 over x, I'm going to be writing 1 over z. So it's lesser than 1 over z, plus, wherever I say 2 over y, I'm going to be writing 2 over z. So write 2 over z, then plus 3 over z. So 3 over z. The left-hand side, which is this expression, as the question said, is equal to 1. So I'm going to be putting 1 here to be lesser than, solving this fraction, we're going to be having 6 over z. So let's cross multiply one more time. Cross multiplying gives z to be less than 6. So from the first step, we saw that z is greater than 3, which is z is at least 4. And here we see that z is less than 6. So we can therefore say that z is either 4 or 5. So writing this expression, which is the intervals of z, we can write that 3 is less than z is less than 6. So we're saying that z is either 4 or 5. So let's go ahead and solve these two cases for when z is 4 and when z is 5. So we're going to be saying case 1. For case 1, we're saying that when z is equal to 4. So that means wherever we see z, we're going to be putting 4 there. And what is the question given to us? We're given 1 over x plus 2 over y plus 3 over z. But in this case, I'm going to be putting 4 there in place of z, since we're saying that when z is 4, and this is equal to 1, according to the question. So let's move this 3 over 4 to the right-hand side. There I have 1 over x plus 2 over y equal to 1. As 3 over 4 moves to the right, I'll be having minus 3 over 4. So let's combine the fraction on the left. Combining the fraction on the left, I'm going to be having y plus 2x all over xy to be equal to, this expression I'm going to be having 1 over 4. Are you seeing that? Cool. So our next step will be for us to cross multiply. So cross multiplying gives 4 times y. I'm going to be having 4y plus 4 times 2x. I'll be having 8x equal to xy times 1. I'll be having xy. So now let's move all the expressions on the left to the right. There I'll be having xy. As plus 8 crosses to the right, it becomes negative 8x. As 4y crosses to the right, it becomes negative 4y equal to 0. Well, in order for us to factorize this expression, we're going to be adding 32 to both sides of the equation. So let's do that. So xy minus 8x minus 4y plus 32. I'll be adding 32 to the right hand side as well. So now let's factorize. What is common here? X is common. Now I'll be having y minus 8 minus, what is common here? 4 is common. Now repeat what is in this bracket here, y minus 8 equal to 32. So we have x minus 4 times y minus 8 to be equal to 32. So that means this expression multiplying this other expression gives 32. So we're going to be looking for the pair factors of 32 in order to get the value for x and y. So let's do that. So I'm going to be writing this here. Our first factor here is x minus 4 and the other factor here is y minus 8. So remember that these two factors are multiplying to give 32. So with x being the largest, so I'm going to be multiplying the highest factor with another factor to give 32. And what are the factors of 32? We have 32 times 1 will give 32. That means this expression as 32 and this expression as 1. So 32 times 1 is going to give us 32. 16 times 2 is also going to give us 32. 8 times 4 is going to give us 32. And then 4 times 8 is also going to give us 32. 2 times 16 and 1 times 32. So now let's get the value for x and y. Now we're going to be moving this negative 4 to the right hand side. So when I move negative 4 to the right hand side, I'll be having plus 4. So it means that I'm going to be adding 4 to each of these terms in order to get the value of x. So x will be equal to, now add 4 to 32, I'll be having 36. 4 plus 16, I'll be having 20. 4 plus 8, I'll be having 12. 4 plus 4 is 8. 4 plus 2, 6. 4 plus 1, 5. Now for y, I'll be moving negative 8 to the right. That means when I move negative 8 to the right, I'll be having plus 8. So add 8 to each of these terms. So 8 plus 1, I'm going to be having 9. 8 plus 2, that's 10. 8 plus 4, 12. 8 plus 8, 16. 8 plus 16, that's 24. And 8 plus 32, I'm going to be having 40. Now remember that x is the largest. That means x is larger than y. Now for which cases, if you notice, you see that here x is smaller than y. So I'm going to be rejecting this where x is smaller than y or equal to y. Then these are accepted. So our pair values of solution is going to be x, y, and z. Let's just manage a space. For the first one, when x is 36, y is 9, and remember our z is 4. Our second one is when x is 20, y is 10, and remember our z is 4. So these are two pairs of solution that we have from this first case. So now let's focus on our second case when z is 5. So I'll be calling this one case 2 when z is equal to 5. So let's substitute z into the given question. We have 1 over x plus 2 over y plus 3 over z. So in place of z, I'll be putting 5 equal to 1. So now I'll be having 1 over x plus 2 over y. And now moving 3 over 5 to the right, I'll be having 1 minus 3 over 5. Because as 3 over 5 crosses to the right, it becomes negative. So let's combine this fraction. Combining this fraction, I'll be having y plus 2x all over xy to be equal to, now this is 1 minus 3 over 5, which will result to 2 over 5. So let's cross multiply. Cross multiplying, 5 times y is 5y plus 5 times 2x is 10x equal to 2 times xy is 2xy. So now let's move this expression on the left to the right. This is going to give us 2xy. As plus 10 crosses, it becomes minus 10x. As 5y crosses, it becomes minus 5y equal to 0. Well, in order to make this expression factorizable, I'm going to be making this value here, which is this coefficient of xy, to be a perfect square. And how can I make it a perfect square? It is simply by multiplying through by 2. So let's multiply through by 2. So 2 times 2xy, I'm going to be having 4xy, minus 2 times 10x is 20x, minus 2 times 5y, I'm going to be having 10y, equal to 2 times 0 is 0. So now let's add 50 to both sides of the equation so that we can be able to factorize this. So adding 50, we have 4xy minus 20x minus 10y. Now add 50 to the left and also add 50 to the right. And now looking at this expression, you notice that 2 can divide through. So let's use 2 to divide through in order to reduce the values that we have. So we have 2 divided by 4xy. I'm going to be having 2xy minus 2 divided by 20x is 10x. 2 divided by 10y is 5y. Plus this is going to give us 25 when divided by 2. And this is also going to give us 25 when divided by 2. So let's factorize. What is common here? 2x is common. So bringing it out. Remaining y minus 5 minus. Now what is common here? 5 is common. Now let's repeat this expression here, which is y minus 5 equal to 25. So now we have 2x minus 5 times y minus 5 to be equal to 25. So let's bring out these two expressions. So we have 2x minus 5 and y minus 5. So what are the factors of 25? I'm going to be starting with the largest. So this is 25, 5, and 1. So 25 times 1 is going to give me 25. 5 times 5 is going to give me 25. And 1 times 25 is going to give me 25. So these are the factors of 25. So let's get the value for x and y. So in order to get the value for x, I'm going to be moving this negative 5 to the right hand side to become 5, which is positive 5. That means I'm going to be adding 5 to each of this term and then divide by 2 in order to get the value for x. So 5 plus 25, that's 30, divided by 2. So x here is going to be 15. 5 plus 5, that's 10, divided by 2, that's going to be 5. And 5 plus 1, that's 6, divided by 2, I'm going to be having 3. So let's have the value for y. Value for y, I'll be moving this negative 5 to the right hand side to become positive 5. So that means I'm going to be adding 5 to each of these terms to get the value for y. So 5 plus 1, I'm going to be having 6. 5 plus 5, that's 10. 5 plus 25, that's 30. And as we see in the question, x is larger than y. So we're going to be removing or rejecting the ones where y is larger. So I'm going to be rejecting this and this since y is larger than x. And we're going to be accepting this. So the only solution we have of x, y, and z here is equal to 15. X 15, y 6, and remember z is 5. So we have 3 solutions from this question. Well, feel free to drop your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.